Now, we're going to take up one more problem on the thermal stresses. Problem of T8, and it reads as a steel rail is laid so that there is no stress in the rails at 10 degrees centigrade. The maximum temperature expected is 45 degrees centigrade. Find the minimum gap between two rails to be left so that the temperature stresses do not develop if the length of each rail is 30 meters. And number 2, stress developed in the rails at the maximum temperature if there is no allowance for expansion. Number 3, stress developed in the rails at the maximum temperature if there is an expansion allowance of 7.5 mm per rail. And number 4, the maximum temperature to have no stress in the rails if the expansion allowance is 15 mm per rail. And similarly, if the stress, number 5, if the stress developed is 20 Newton per mm square, what is the gap between the rails at the maximum temperature? So to do that, so here first we are going to take the change in temperature. So here 45 minus 10 degrees is 35 degrees centigrade is the change in temperature. So what is the minimum gap so that there is no temperature stress? So that means it will go to have the free expansion of the rail. The free expansion of the rail will be alpha into T into L, which is equal to coefficient of thermal expansion alpha into temperature change into length of the member. So the length of the rail is given to be 30 meters. So you are going to get it as 30 into 1000. And then the temperature change is 35 degrees centigrade. And then the coefficient of thermal expansion is 12 into 10 to the power of minus 6. So on simplification, you are going to get delta as 12.6. When there is no, it's the free expansion. So next, stress for no allowance for expansion. So when there is no allowance for the expansion, so what happens? Sigma T will be equal to alpha into T into E. So alpha is again 12 into 10 to the power of minus 6. T is the temperature change, which is 35, into Young's modulus is 2 into 10 to the power of 5. So the stress developed will going to be 84 Newton per mm square. And number 3, the stress for an expansion allowance of 7.5. So that will be 7.5 mm. So that will be sigma T will be equal to alpha into T into E minus delta 1 into alpha into T into L minus delta 1 into E by L. So alpha is the coefficient of thermal expansion, where T is the temperature and L is the length of the member, and delta 1, which is nothing but the expansion allowance, what you are going to get into E by L. Where if you simplify that, so when you just enter into multiplication, alpha into T into L into E by L, so LL will get cancelled, so alpha into T minus delta 1 into E by L. So if you then substitute the values, alpha into T what we have is 84, alpha into T which is 84 minus then delta 1 is 7.5, that is the expansion allowance, into E 2 into 10 to the power of 5 divided by L, which is 30 into 10 to the power of 3, so or 30 into 1000. So on simplification, you will going to get that value as 34 Newton per mm square. Next, we will going to have the temperature, maximum temperature for sigma 1 is 0 if delta 1 is equal to 15. So sigma T is equal to alpha into T into L minus delta 1 into E by L again. So here, that is alpha into T will be equal to delta 1 because sigma T is 0. So since it is 0, alpha into T into L, when you open the bracket, alpha into T into L into E by L will going to give you alpha into T, which will be equal to delta 1 by L because EE will going to get cancels there. So then you will going to have 12 into 10 to the power of minus 6 into temperature change. That is what we need to find out because the maximum temperature for sigma 1 is 0. If delta 1 is equal to 15 by 30 into 10 to the power of 3. Therefore, the temperature will be 41.67 degrees centigrade. So if sigma T is 20 Newton per mm square, what is the gap? That is what is delta 1. So that is again sigma T will be equal to alpha T into L, alpha into T into L minus delta 1 into E by L. So what is the gap? That is the delta 1 we need to find out. So alpha into T into E minus delta 1 into E by L. So that will be sigma T is 20 Newton. So you take 20 Newton equals minus 20 Newton and alpha into T into L, we have alpha into T into E, which will be equal to 84. Since I want to find out the value of delta 1, because what is the gap that will going to be considered, so delta 1 into E is 2 into 10 to the power of 5 divided by L is 30 into 10 to the power of 3. So therefore the value of delta 1 will be 9.6. So this is how you will be able to find the solution. And if the stress developed at the maximum temperature is 20 Newton per mm square, then the gap is 9.6. So that is the interpretation what you will going to get. So here, when you have the stress developed of 20 Newton per mm square, that is what will going to be the maximum temperature, then the gap at that particular temperature will be, which is at which will be of gap of 9.6. So this is how you will be able to find the solution. Thank you.